So here I'll do a much more complicated example. I'm going to highly suggest at this point we move down either the second row or the second column. I'm going to go ahead and pick the second row. Most of the things are 0 except for this 3. And if I look at my checkerboard, here's a plus, here's a minus, here's a plus, and this 3 would be a minus. So negative 3 times, deleting that row and column, leaves me with 1, 0, minus 2, 0, 2, 0, 4, 3, 0, minus 4, 8, 1, and 2, 0, 3, 0. At this point, I'm going to go down the second column because once again it has lots of zeros. So this negative 4 is in a plus, minus, plus, minus spot. So it's going to become a positive 4. And we'll delete that row and column. I'm left with 1, minus 2, 0, 2, 4, 3, 2, 3, 0. Once again, I'm going to suggest going down this third column since it has lots of zeros. So this 3 is in a negative spot. So negative 3 times 4 is negative 12, times my new negative 3. And then deleting that row and column, I'm left with 1, minus 2, 2, 3. Negative 12 times negative 3 is 36, times 3 minus negative 4. So 36 times 7 gives us a determinant of 252. So there is another way to calculate determinants of 3 by 3 matrices that is similar to 2 by 2. It does not expand nicely to higher matrices. My last example I wouldn't be able to use this method, but it is another way to do it. So we start by writing a second copy of the first 2 columns to the right of the matrix, and then we find the determinant by multiplying entries on the 6 diagonals. We add the downward diagonal products and subtract the upward diagonal products. So for this example, the first step is to rewrite columns 1 and 2. And then we're going to multiply along the 3 diagonals. So we'll start with the downward diagonals. And there are going to be 3 of those. The first one is the main diagonal, 1 times 8 times negative 6, which is minus 48. The second, negative 4 times 5 times 7, which is minus 140. The third, 3 times negative 2 times 9, which is negative 54. The next are the 3 upward diagonals. 7 times 8 times 3, which gives us 168. The second, 9 times 5 times 1, which is 45. And then the final, negative 6 times negative 2 times negative 4, which is negative 48. So we'll add the downwards and then subtract the upward diagonals. So negative 48 plus negative 140 plus negative 54 minus 168 minus 45 and then minus negative 48, which gives a determinant of negative 407. So to end this, I want to talk about 3 different properties of determinants. The first one, a square matrix is invertible if and only if the determinant of A is not 0. So this adds on to the invertible matrix theorem. So if we want to know if a system of equations has a solution, or is it linearly independent, or does it span, we can do that by simply determining what the determinant is. If the determinant is 0, it doesn't have a solution, it's not independent, it doesn't span. If it's not 0, then the system would have a solution, the columns would be independent, and they would span. 2, the determinant of A is equal to the determinant of A transpose. So this comes from the fact that I can do cofactor expansion on either a row or a column. The only thing the transpose does is switches rows and columns. So it's not actually going to change anything. The final one, determinant of AB is equal to the determinant of A times the determinant of B. So this one is very, very nice when you're dealing with theory and proving things. And I'm going to highly suggest that number 3 you use for problem 5 in your homework. So that should give you the hint that you should be multiplying some matrices there.